Let's see how to make this a Spring Boot application. Following is the very minimum you have to do to make this, or in fact any Java application, a Spring Boot application. First, create a main class extending from the Spring Boot Servlet Initializer class. Then add the Spring Boot Application Annotation to that class. Finally, add the main method. Now let's look at each step in detail. First, create a main class. You can give any name to it, so I'll name it ComponentApplication. This main class should be placed in the root package. And this allows for ComponentScan to apply on the whole project. So the package structure of this project looks like this at the moment. There is com.comment.controller package where I have the comment controller class, and then the com.comment.entity package which has the comment class, and it goes on like this. So the root package is com.comment, and this is where I want to place the main class in. Next, adding the Spring Boot Application Annotation. This is a convenience annotation that is equivalent to declaring these three annotations: EnableAutoConfiguration, ComponentScan, and add-configuration. So what do they do? First, let's look at EnableAutoConfiguration Annotation. As the name suggests, this enables the auto-configuration of the Spring application context, attempting to guess and configure beans that you're likely to need. If you have worked with a typical Spring application, you should be familiar with all the configurations that are needed, such as data sources, entity manager factories, dispatcher servlets, and the list goes on. By enabling auto-configuration, the Spring Boot framework kind of looks at the jar dependencies that you have added to the application and the existing configurations for the application if there is any, and then based on these automatically configures your Spring application. For example, if you have H2 on your class path and you have not manually configured any database connection beans, then Spring Boot auto-configures an in-memory database. How convenient is that? Next, ComponentScan Annotation. This is the annotation which we can use to tell the Spring framework where to scan for beans. That is basically the classes annotated with @component, @service, or @repository. So when this annotation is on a particular class, the package of that class and all of its sub-packages will be scanned for beans. That's why we want to place the main class in the root package so that all the beans could be found. Last one is the configuration annotation. This basically allows to register extra beans in the context. Spring Boot favors Java-based configuration, and in the documentation it is said that although it is possible to use Spring application with XML sources, we generally recommend that your primary source be a single configuration class. Usually the class that defines the main method is a good candidate as the primary configuration. So I guess that explains why it is bundled in the Spring Boot Application Annotation. So now we've annotated the main class with the Spring Boot Application Annotation, it is time to add the main method. And in the main method, we delegate to the static run method of the Spring application class, providing the main class and the args as parameters to launch the application. Now I'm going to create the main class. In the com.comment package, which is the root package. ComponentApplication is the name of the class. It should extend from the Spring Boot Servlet Initializer class, so I'm adding that here as the superclass. I'm also going to tick this box, which will generate the main class for me. All done, click Finish. Adding the Spring Boot Application Annotation to this class. Now I'm calling the static run method of the Spring application class, passing in the main class and args. Now I'm going to run this as a Java application to see if it will launch as a Spring Boot application. Well, as you can see, now there is an illegal argument exception, and it says comment is not a managed type. So now I have to mark comment as an entity. But why would Spring Boot complain about the comment class? It is just a plain Java class. Well, I have mentioned the comment class in the comment repository, which extends from CRUD repository. That's the reason why it complains. So of the two generic types of the CRUD repository, first one should be an entity, and the second one should be the type of the primary key of that entity. So the comment class should be annotated with @entity annotation. Now, because I have enabled auto-configuration at the root package, all the sub-packages will be scanned for entities. Otherwise, I'd have to use the entity scan annotation to tell Spring Boot where to find the entities. I'll run the application again. Now there's another problem. No identifier specified for entity comment. Now I have to annotate the primary key of the comment with @id annotation so that it's recognized as the primary key. And run it once again. Now that it started successfully, I'll get back to the integration test. I've fixed some typos here if you've noticed. Organize inputs. And now I'm going to run this as a JUnit test. Okay, here we have the results. It has failed. A session error says the status expected 200 but was 404, which means the requested result was not found. So how do we go about this? HTTP status code 404 means not found. What was not found? Of course, the resource. What resource was requested? Well, comment is the resource that was requested. So we have a class to represent the resource, which is comment. And in order to serve the resource, the comment controller class was created. In Spring's approach to building RESTful web services, HTTP requests are handled by a controller. But then how is this controller identified by the framework? Annotations, of course. That means it's time that I add the appropriate annotations to the comment controller. So now when I add the REST controller annotation to this class, Spring Boot will pick it up as a resource controller to serve the incoming HTTP requests. Again, REST controller is a convenience annotation that is itself annotated with @controller and @response_body. Response_body annotation indicates that a method's return value will be sent in the response body. Because this is at the class level, it applies to every method in the controller. Now, the framework should know which method to be called depending on the HTTP method and the URI of the request. So for that, there are a few annotations that can be used. There is request mapping annotation, which can be used on both class level and method level. Then there are the HTTP method specific variants: get mapping, post mapping, put mapping, delete mapping, and patch mapping. These are method level annotations. Because this method is to serve a GET request, I'm going to use get mapping on this. And then I have to pass in the request URI or the path that this method would serve. So the request URI is post/1/comments, where 1 is the post ID, which is a path parameter. So it should be represented with a name inside of curly braces like this. The method parameter should also be annotated with @pathVariable annotation, giving the name of the path parameter, which is ID here, so that the value of the path parameter will be set to the method parameter, which is post ID. That's all there is to be done in terms of handling the request. But if I run the test at this point, it'll throw a null pointer exception, because the comment service here would be null. I want the framework to inject an instance of comment service here. For that, I'll have to do two things. First, this has to be annotated with @inject annotation. Or you could use the AutoWire annotation as well, which is Spring specific. But I prefer the @inject annotation. But it cannot be injected or auto-wired unless it is a type managed by Spring. So how do we make the comment service a Spring component? There is this @component annotation, which indicates that an annotated class is a component. Such classes are considered as candidates for auto-detection when using annotation-based configuration and class path scanning. Also, there are a few specializations of this annotation, such as @controller, @service, @repository. So I'm going to use @service annotation on the comment service class because it is a service. Following is an excerpt from Spring documentation, which is worth noting here. @component is a generic stereotype for any Spring managed component. @repository, @service, and @controller are specializations of @component for more specific use cases in the persistence, service, and presentation layers respectively. Therefore, you can annotate your component classes with @component, but by annotating them with @repository, @service, or @controller instead, your classes are more properly suited for processing by tools or associating with aspects. For example, these stereotype annotations make ideal targets for point cuts. @repository, @service, and @controller can also carry additional semantics in future releases of the Spring framework. Thus, if you are choosing between using @component or @service for your service layer, @service is clearly the better choice. Similarly, as stated earlier, @repository is already supported as a marker for automatic exception translation in your persistence layer. So now that I have annotated the comment service class with @service annotation, the comment repository dependency here should also be annotated with @inject. Now, if you're wondering how the comment repository interface will be injected here because interfaces are not instantiated, it is all done by the Spring Data Framework. All I have done to enable the functionality is that I have enabled auto-configuration, which in turn enables JPA repositories. Because I have Spring Data JPA as a dependency in the class path, Spring will scan com.comment and all its subpackages for interfaces extending repository or one of its sub-interfaces. For each interface found, the infrastructure registers the persistence technology-specific factory bean to create the appropriate proxies that handle invocations of the query methods. Each bean is registered under a bean name that is derived from the interface name. For example, the comment repository will be registered as comment repository with a lowercase c at the beginning. So I don't have to do anything to the comment repository interface since it extends from CRUD repository, which in turn extends from repository interface. It is already eligible for auto detection and dependency injection. Okay, now that I have wired everything up, I will run the integration test once more. Now, here we get another exception. It says, you are trying to execute a streaming query method without a surrounding transaction that keeps the connection open so that the stream can actually be consumed. Make sure the code consuming the stream uses @transactional or any other way of declaring a read-only transaction. So this is about the comment service which consumes the stream returned by the repository. I'll just extract this as a local variable so that it's more visible. There are two things which has to be done here. First one, although not complained where an exception yet, is to close the stream. This is very important because instead of fetching the list of comments all at once and then wrapping it in a stream, what happens is that Spring Data Framework leverages the JPA provider specific methods to perform the streaming. which is way more efficient. So it is mentioned in the Spring documentation that a stream potentially wraps underlying data store specific resources and must therefore be closed after usage. You can either manually close the stream by using the close method or by using a Java 7 try with resources block. So I'll use the try with resources block to consume the stream. Since the stream is auto-closable, it will be closed soon after it is consumed, regardless of success or failure. The second issue is what the exception is about, is that Spring expects a streaming query method to be executed within a read-only transaction. I haven't added any transactional semantics to this method, so before moving on with that, let's look at some basics of Spring Transaction Management.